So when you're matching equations to a graph, the easiest and best way is going to use the function transformations, which I see either you or someone else wrote some nice notes here. So the first thing I notice is that this is an upside down U, so it looks like an upside down parabola where it's concave down, which means that your x squared, that has to be a negative number out front. If your leading coefficient is negative, then you have the upside down. That's why A and C are not correct, because that's positive with x squared, that's positive with x squared, so that would be a regular U. So automatically, B and D are the only possible answers, and now we're just going to go look at the y-intercept over here. It looks to me like that's between positive 740 and 760. That's negative, that's positive, and the regular constant is always going to be your y-intercept. Since that's negative, that matches the upside down. That's positive 645, which matches the y-intercept I see over here. And this next one, with that silly rabbit hopping around, it's asking, how long will it take for the bunny to reach its maximum height? And then what is that maximum height? And I notice that's t squared, so that's a quadratic equation. And whenever we're looking for maximums, that means we are going to be searching for the vertex of that equation. Now, I think the best vertex strategy to just memorize is that if you want the x value, which we call h, we're going to say that is going to be negative b over 2a. And that is going to, h is always the x value of the vertex. And then we can plug that back in to get the y value. And typically, the x value is your time. The y value, when you get that answer, will be the height. So over here, I'm going to put negative b over 2a. So negative b will be negative 1 over 2 times a, which is that negative 0.2. So that'll be negative 1 over negative 0.4, which gets me 2.5 for the x value. The puppies are playing. They're also helping the video a little bit. Okay, so that's the x value. Like I said, that is the time it takes to get to the maximum height. So it's going to take 2.5 seconds for the bunny to get to her max height. But now we need to plug that back in to the original equation to see the actual height. Just by doing our classic plugging in over here. When you plug that in and start working it out, 2.5 squared times negative 0.2 gets us negative 0.125. 1 times anything is itself. And so our answer is 2.375 for the output, which will be the height. So it's going to take that rabbit 2.5 seconds to get 2.375 feet up in the air. Number 4 is asking, for what value of k will you have to have in order to have no solution for the systems of equations? Now, a system of equations only has no solutions if the two equations are parallel. If you remember, parallel lines have the same slope, but a different y-intercept. Different y-intercept. So we want to know what value of k will give these two lines the same slope. So I'm going to label these as equation 1 and equation 2 so I can go to play around with them a little bit. We know a lot about equation 2 over here. We don't have any missing values. So I'm going to take 4x minus 5y equals 7. And the quickest way to check if they have the same slope is to solve this bad boy for y. So I'm going to subtract 4x. I'll divide by negative 5. And I'll divide everything by that negative 5. So it looks like over here we have y equals 7 over negative 5 equals a negative over a negative, will be a positive 4/5 x. And that was for equation number 2. So if the other equation gets 4/5 x, that means these lines are parallel and it's impossible for them to have a solution. So let's go take this equation up here and we can start solving it and start getting a little bit closer. So I'm also going to take equation number 1 now and solve it for y. I'll subtract kx this time. then divide by that -3, and I'll sort of separate it up. So we get y equals 4 over -3, and negative over negative also turns into positive kx over 3. Remember, k is some number that we don't know over 3. And so here we are. We see that the slope over here is 4 over 5. We see that this is some number over 3. We need to figure out what value of k will make these the same. So what I'm going to do is I'm going to take my slope of 4 over 5. And I'm going to set that equal to the slope of the other one, which is always with x. In this case, it's k over 3. Now we can solve this. The only thing I need to do to get rid of k is the opposite. So I'll multiply each side by 3. And I end up getting 12 over 5 equals k. So 12 over 5 is going to be our answer, which is answer choice A right there. We're writing, first we have to write an equation for plan 1 and plan 2 about how to save. No matter what, we're starting with $1,000, and then we have other ways, 2 different options for how it's going to grow. So first, for plan 1, since it says it's growing at 7% every year, it's growing by 7%, this has to be an exponential function, because exponential functions always take care of patterns that are multiplying or that changed by a percent. So since we're increasing by 7%, we need to use y equals a times b to the x, where a is the start and b is your multiplier change. Okay? So no matter what, in both plans, we're starting with $1,000, and now we need to figure out what's the multiplier going to be raised to the x exponent. So since we're doing the 7% increase, you always start with 100%. And since we're growing our money, we're adding the 7%. So every single year, we're going to get 107% of our money. And if we put that percent as a decimal, you get your 1.07 that's needed. So there's the equation that's needed for plan 1. Plan 2 says that $100 will be added every single year. So since it's just a $100 add, that's going to be linear. Since linear functions always deal with adding and subtracting the same amount. So over here, we're just going to have that he starts at $1,000 and we'll add 100 times x, which will stand for the number of years. So those will be our 2 different equations for plan 1 and plan 2. In order to solve a radical equation, so I see the square root of 5x plus 11, that chunk needs to be isolated. So I'm first going to start by adding x to get that x plus 1. Now we need to do our inverse operation to get rid of the square root. And if you remember, roots and exponents are inverse operations. Since that's the square root, we assume there's a little 2 there. I'm going to use the exponent of 2 on each side, wrapping both sides completely. And those will undo each other, so we're just left with 5x plus 11. And then x plus 1 squared just means I take that parentheses and expand it out twice. And now I can see the double distribution. X times x is x squared. X times x is x, times 1. 1 times x is x. 1 times 1 is 1. Combine our like terms. And we can bring that over here. Now, since this is a quadratic equation with x squared and regular x, I need to get one side equal to 0 before I can solve this quadratic. So I'll subtract the 5x, and I'll subtract the 11. So I get 0 equals x squared minus 3x plus 10. And now we can factor. What multiplies to 10 and subtracts to 3? Oh, and 1 minus 11 is negative 10. Sorry about that. Negative 10. So now negative 5 and 2 gets us negative 10, combines to get negative 3. And then we'll set each of these equal to 0 and solve. X will equal 5, and x will equal -2. So once again, you're being asked to solve. I see x squared and x, so this is quadratic. One side's already equal to 0, so I can start trying to factor. I see a number with x squared, so I need to try and factor out that GCF. 4 times x squared gets us to 4x squared. 4 times -2x gets us back to -8x. 4 times -3 gets us back to -12. And now we're ready to factor. What multiplies to -3 and combines to -2? -3 and 1. Set each factor equal to 0. And solve. X equals 3. X equals -1. Now with this one's a little more complicated. We're given an equation, we're given a function statement that the f of 12 equals 6. Then we want to know what happens if we plug in -8. Before we can do that, we can't have two different variables, x and b. So we need to use this fact up here, that when you plug in 12 for x, we get the output of 6. So I'm going to set that up. And that is your output. So I'm going to plug in. So the output can replace the f of x, 6. 12 is what we're plugging in. 5 over 4 times 12. And that should be enough information for b. That's what we plug in. That's always what we get as our answer. So now we can make this happen. So 6 is equal to 60 over 4 plus b. 6 is equal to 20, nope, sorry, that's 15 plus b. I can subtract that 15 and get -9 equals b. So I know that the actual f of x is 5 over 4x, and then I know my b is actually -9. And now I can plug in the -8 and PEMDAS that down.